Hey guys, and welcome back for another lesson on inequalities. This time we're solving combined linear inequalities. I hope you joined us for our introductory lesson to inequalities as well as our solving linear inequalities lesson. If you haven't seen those lessons yet, I'm linking them down in the description below. Please check those out before you go any further. Now, if you're new to Team Danielson, let me just explain how this is going to work. I'll start you off with a lesson, including some examples, and then I'll leave you with a pause and practice exercise, and the answers will be taken up at the end. Let's get started. Now, this is a combined inequality that's already been solved. As you can see, it's an inequality that involves two boundaries, an upper boundary, which is my 3 here, and a lower boundary, which is my -3. Now, the upper boundary is colored in because, as we can see here, b is less than or equal to 3. If the inequality is underlined, the number line circle is colored in. If the inequality is not underlined, like this one here, it shows that b is greater than -3, but not equal to -3. So we've got an open circle on the lower boundary, -3, and a line coming up from there, all the way up to and including 3, which is my upper boundary. Now, up until now, we haven't really been looking at combined inequalities. We've just been looking at separate inequalities where maybe we said that b is greater than -3 or b is less than or equal to 3. But here we are combining the two together to make one inequality which is bounded on both ends. Let me show you how we can solve a combined inequality like this. As you can see here, I've got an expression, 2x plus 3, which is greater than 7. Now, 7 is the only term in the expression in the middle of this combined inequality. And 7 is greater than or equal to this expression, x plus 3. So to solve this combined inequality, what I first need to do is to split this combined inequality into two separate inequalities. We'll first say that 2x plus 3 is greater than 7. That is, the expression on the left-hand side of this combined inequality is greater than the expression that's in the center of the combined inequality. And another inequality that we could write is that 7, which is the expression in the center of this combined inequality, is greater than or equal to x plus 3. So we've got two inequalities that need to be solved here. Let's start with the first one first. So the one I've highlighted in yellow, 2x plus 3 is greater than 7. To find out what x is, we need it on its own. X is being multiplied by 2 and 3 is added. So working backwards, first we'll subtract the 3 and then we will divide by 2. So x is greater than 2. Remember, we never just say the answer is 2. 2 is just a boundary value, a critical value. X could have any value greater than 2 so far. Let's see what the other boundary is. So now on the other side, we've got 7 is greater than or equal to x plus 3. We want the x on its own, so we need to get rid of the 3. So plus 3 on the right side becomes minus 3 on the left side, and we end up with 4 is greater than or equal to x. Now we've got two separate inequalities, two different critical values or boundary values to define what x could possibly be. To recombine this inequality, we'll put our values in order from smallest to biggest. So 2 is the lower boundary, it's smaller than 4. So 2 and then 4. And we'll put x in the middle. And then make sure you get the inequality direction correct. But in this case, looking at this simple inequality, x is clearly on the bigger side of the inequality sign. So over here, I'll make sure that I have 2 is on the less than side and x is on the bigger side. And in between x and 4, x is clearly on the smaller side. So here I'm going to make sure that I have x is smaller than or equal to 4. Let's try another example. So here we've got one term is less than, now here we've got a two-term expression, 2x minus 7. And then we've got 2x minus 7 is less than or equal to 8. So let's split this into two separate, simpler inequalities. First, we'll say that 3 is less than 2x minus 7. And then separately, we'll set out another inequality to solve, which shows that that middle expression, 2x minus 7, is less than or equal to 8. And we'll solve these two inequalities separately. So starting with the one over on the left-hand side, I want the x on its own. X is being multiplied by 2 and 7 is taken away from it. So first I will move the 7. Opposite of minus 7, I plus it. And then I want the x by itself. I need to get rid of the 2. The 2 is multiplying, so I will divide by 2. That gives me 5. But don't ever say that your answer is 5. 5 is not your answer. In fact, x cannot even be 5. This symbol here shows me that x is greater than 5. For the other inequality, again, we want to get x on its own. So x is being multiplied by 2 and 7 is being taken away. Let's start by moving the 7 to the other side, opposite of subtract. We will add it. And then we want to get the x on its own. We need to get rid of the 2. Opposite of multiplying by 2, we'll divide by 2. So we've got 7.5. But again, x is not equal to 7.5. X is less than or equal to 7.5. X is on the smaller side of this symbol, and this symbol is underlined. Again, to combine that inequality, to combine those two inequalities together, let's write them in order from smallest to biggest. 5 is smaller than 7.5. We'll put x in between, and watch out, make sure we get these symbols right. Is x bigger or smaller than the 5? X is on the bigger side. Is x bigger or smaller than the 7.5? X is on the smaller side. So we've got those symbols in the right order. Notice my numbers go from smallest to biggest, and my symbols also go from smallest to biggest, starting with the pinch down side on the left, and they get bigger as we go across to the right. That's the way we want to see them, but it doesn't always work out that way. Reminders before we get on to some practice. When solving inequalities, do not give a number answer. We're looking for a range of values. Is your variable greater or less than, or greater than or equal to, or less than or equal to? Underlined inequalities mean to include the boundary values. We solve inequalities the same way we solve equations, but the big exception is when we're multiplying or dividing both sides of an inequality by a negative value, the direction of the inequality changes. Combined inequalities need to be broken into two separate inequalities to solve. To recombine those inequalities, we list the boundary values in order from smallest to largest with the variable in between, and take very special care with the direction of the inequality signs. So far, we've been getting lucky, but we will show you some exceptions in the future, so don't assume it's automatic. Now, time for some practice. Remember how we split these combined inequalities into two separate parts? Solve them as you would normally solve an inequality, and then we recombine them, putting our values from smallest to biggest, our variable in the middle, and be careful with how you put those inequality signs. Go ahead and hit pause, work these out, and hit play when you're ready to see the answers. I hope you had a chance to hit pause. Here come your answers. For the first row, the second row, and the last row. I hope you've noticed that in each case, my numbers go from smallest to biggest, my variable is in the middle, and my inequality signs go from smaller to biggest. But if you're with us for our introductory lesson to inequalities, you'll see that that's not always the case with combined inequalities. If you haven't yet seen that video, I really highly recommend it. Have a look at the description section down below. In any case, I hope you found this practice and lesson helpful. If so, go ahead and give me a like. If you found that there was anything I've left a bit unclear, please leave me a comment so that I can clarify for you. And if you're looking forward to the next lesson as much as I am, please subscribe so you can see how we tackle quadratic inequalities. It's a good one. Keep practicing till then, and I'll see you soon.